technologies. Yeah, okay, I'm going to start again. Hello and welcome, everyone. Let me just start my presentation. I'll do a bit of intro and then we'll take it from there. Let me just start sharing. One thing that I can't see for some reason is, let me just close this, is here we go. And I'm going to share my screen. Here we go. And once I've loaded my presentation, can you see my screen, by the way, at the moment? Just wanted to quickly check.
Yes, we can. You can see your desktop.
Perfect. Thank you very much for that. So let me get started. So today I'm going to talk about what are different, smart cities. We've heard about this before. What are like connected kind of cities at the same time as well? What does it take to create that kind of an environment? So as my colleague talked about myself, what my experience is, I've worked as a networks engineer for about 6 years in the beginning of my career after doing my MSc in IT. And in that, I was involved in building data centers, and also we used to work with different devices, IP converged, like cameras, access control systems, and all those. And I was the lead for that. So we used to deploy these systems for building management systems to make the building smarter. Now we're talking about cities. And at that time, I'm talking about back in 2008-9 and starting from 2005. So there are a lot of things that are happening around the world. So I will be talking about what the journey is like, where we are at the moment, what are we looking at in the future, and what our customers are doing with these technologies, and what is available to you as a customer if you want to use, let's say, a technology to remotely sense something. It might be you are trying to sense some kind of tsunami kind of alerts or something else. So all that can be done, traffic analysis and building management systems, environmentally friendly practices in different regions as well. You can do that. So let's get started. Now, looking back at when it all started, I mean, we used to have a version 1.0. Now we are more on 2.0 kind of a version. So 1.0 was very simple, basic kind of connected devices. At that time, it was just the emergence. And we're talking about early 1980s, actually. And at that time, for example, Coca-Cola wanted to check if their vending machines have got cold drinks or not. So at that time, they wanted to sense these things through ARPANET. So, the internet works based on that kind of, standard. At that time, they wanted to connect different vending machines to check what's going on there, if they are chilled or not, if they need to increase the temperature of, the refrigeration, or they need to replace them or load the new, the drinks in there as well. And then a lot of people did lots of experiments. But the problem was, it was all ad hoc and lots of experimentation failed because there was no strategic kind of roadmap of what we are trying to achieve from this. And then there were organizations, there were different companies who started thinking about what do we need to do? Why? How can we make it more scalable and useful? In that, you needed some kind of data as well. Without data, you could not, plan certain things of how it would impact somebody, what is required basically as well at the same time. So the focus had to change. It had to shift to citizens, basically. How a community, a country, a region can benefit from this technology rather than, small kind of projects, basically. If we want to make it scalable, if we want to have an impact, it has to impact people's lives as well at the same time. So this is where we are at now. It's more strategic. We are planning how we can use drones to sense different things as well. We can check weather patterns. We can check seismic activity as well. We want to check if there is going to be an earthquake or something like that, if there are traffic jams, anything that you can think of. We are planning to work on that. And also there have been lots of wildfires, there have been lots of, so especially when urban designers, they design a city, urban planners, they need to think about how much water is available. how to sense that, how to check it, how can they keep track of what's going on with water facilities, with regards to what kind of terrain it is basically, and also how we would plan different hospitals and things based, it's all based on data. So now it's more strategic, government related kind of things are happening on there as well. I'll give you some examples of that in a minute. Now, so this is kind of a journey of what we started off with lots of failed experimentation, and then now it's more of strategic kind of decision making on the roadmap basically. So if you think about smart cities, they are not, this is not one single simple kind of a solution. There are lots of complexities involved in it. So if you look at this image, you can see that, there are different kind of engagements. And at the bottom, you can see there are lots of the business of the government. The government needs to do a lot of things. They are worried about sustainability. They're worried about the jobs. They're worried about workforce development, security, Internet of Things. So that comes into play as well. And analytics, because they need to analyze what's working, what's not working, how can we improve certain things as well. And in terms of engagement, we've got like call centers, 999, 911, those kind of numbers that can be used. So there is a solution for contact centers. Amazon Connect is one of the solutions for that. So in terms of comprehension, if you need to look at an image or speech or something and try to understand what it is or what it means, or so those are the kind of things also which are involved in it. Transcription, translations, there are lots of apps out there, like Duolingo is an example of translation app, where if you want to learn a language, you can use that. It's based on AWS as well, so you can use it to learn different languages. So those are the kind of things as well you can do. Speech to text kind of thing, text to speech also. So there are lots of different things, and also image analysis. So if you want to find out if there is an accident, the image would be captured by a camera, let's say, and that would actually trigger something, and the algorithm will find out if this is an accident or if it's very close proximity or anything like that basically. And it can be used in so many different ways. So in healthcare, you can use that image analysis, body cam, you can use, and then remotely you can monitor what's going on, what's the situation on the ground for if there is an incident or something like that. You can control the water supply, you can check the water levels, you can control the lighting of a building, as I was talking about the smart buildings earlier on. Parking, traffic, all that kind of thing. And then, so this is V2X, which is vehicle to the surroundings, so vehicle to everything. So a car, an autonomous car or something which is driving now, which is driverless actually. We need to find out if that car can understand its surrounding. It's not going to bump into somebody. It's not going to bump into a barrier or something else. So it needs to be aware of its surroundings. So those kind of things. Airports can use that. And, Department of Transport uses these kind of technologies. It's very useful for them, basically. Connected hospitals. For elections, you can use it. Public health. So with COVID and all those kind of things, recently we have witnessed it as well. The governments wanted to find out where more cases are, where is capacity in the hospitals, what kind of, equipment, or what kind of, how much oxygen is required by the hospital and things like that. So all that was possible because of the data available to them. And based on that data, you can create algorithms. They can make a decision, they can predict something, they can tell you in a couple of years time or couple of days you will run out of something, so you need to be careful. Recently in the UK, the water level has been quite low, and lots of sensors on the field have been collecting how much water is available. And also at the same time, there is a drought kind of a situation, because lots of gardens, lots of lawns and parks have turned brown because there was not much rain. So those are the kind of things, and where the water should be channeled, how it can be improved, the land itself as well. So all those things, they are different domains. They require different technologies to be able to work. It's not just one size or one solution that you can use for everything, basically. Is there any question at this point, by the way? Okay, thank you very much for that. Couldn't see anything. So if you've got questions, I'll give you some time in the end as well to ask me any questions if you want. Now, in terms of IoT, when we talk about Internet of Things, so we've got in AWS more than 200 services in total, but some of those services are related to IoT specifically, and lots of other services, database, compute, and others. But some of those services are related primarily to IoT itself, Internet of Things. So you have got like IoT Core, which is available to you to connect different devices and then monitor them remotely. You have got green grass and free RTOS, which is the real-time operating system. So you can actually deploy a lot of different devices. So let's say somebody has developed a device, you can give them a lightweight kind of software that they can load onto that device for monitoring purposes, for different uses that they want to, use it for, to make it easier for developers or hardware manufacturers to be able to incorporate these kind of softwares in it. Lots of Linux-based operating systems are used by a lot of airlines for their infotainment systems and other things as well. So these are very lightweight kind of operating systems, not heavyweight. So they can easily be installed into a small microcontroller on the field, which would sense something and send data to a central hub where the data would be analyzed. So there are so many purposes these kind of services actually serve. So these are AWS services I'm talking about here. It can be used for street lighting. You can use it for parking, transportation. You've got water management systems, if that's the domain you're working with. You've got efficient resourcing. That's the outcome, basically. That's the benefit of it. Balanced budget, safe kind of citizens as well. Of course, it's about transportation. It's about, the environment and innovation. So you can innovate out of these kind of technologies. You can think of what I can develop rather than developing the whole solution from scratch. You've got some platforms available to you which give you the capability to build on top of it rather than you starting from scratch all the time, basically. Now, that's one thing that you can use. The other thing is analytics. So in terms of analytics, you've got Amazon EMR, Elastic MapReduce. We've got Amazon Kinesis, and then we've got Redshift. So EMR is used for, big data kind of storage. If you want to use it, Apache, Hadoop, and those kind of things, you can use that for managing those kind of clusters. You can actually use Kinesis for data streaming, video streaming, those kind of things as well. Lots of data can be consumed through that service. There are multiple options in that video data, and you can do a lot of analytics on there. And also for data warehousing, all that data that you're collecting from so many devices across the globe, probably, you need to analyze it, you need to store it somewhere, and then you need to do business intelligence on that. You need to find out insights from that data. So you can use Amazon Redshift for that. So that is a very good option for you for analysis as well. You need to capture it. You need to, first of all, have a system which is distributed, which is controlled. Then you've got that data streamed to a central location somewhere, and then that data can be analyzed. So you can improve the traffic analysis. You can predict different things, basically based on that data you're collecting. Energy efficiency as well, of course, based on that. In IoT, Internet of Things, you would do a lot of actuation as well. So you've got sensors which sense something, but something needs to be done. So let's say a building is empty. You're not using that building. So all the lights are on in that building and air conditioning is on. You don't want to keep it on. for no reason. So based on that data, a decision can be made, and the actuators can shut down those things basically. So those are mechanical kind of devices, or even, they don't always have to be. They can be a switch, which is a solid state kind of a switch, which can do that. As long as it's programmed properly, they can actually shut down those extra lights in the building. They can shut down the extra systems that are not required in the system or the building as well. Data lakes and machine learning. So you can have different types of data, unstructured, structured data in data lakes, and you can apply machine learning on things to, instead of somebody trying to work out what's going on, machine learning can be used for that as well. And we've got lots of capabilities in terms of machine learning as well in AWS. Again, it's improved efficiency. You've got a reduced cost structure is a benefit. You've got newer revenue resources as well. You can develop systems that can be used for different purposes. As I said, you might come across a problem, because all we want you to do is find out the problem and try to find a solution. And you'll have tools that you can use to build a solution, but you need to know where the problem is and what kind of solution is best case for you. And that's why we've got so many different kinds of services that you can mix and match. You can put the pieces of the puzzle together to create a solution, instead of having a one fixed solution that is not flexible. So that's also what you can do in terms of analysis. And the next thing is AI and ML. So they play a very important role in terms of artificial intelligence and machine learning. So you've got mobile hub as well, where you can create, test, you can develop different kind of mobile based applications, and you can test them, you can deploy them as well. Then you've got Amazon Lex. The Alexa is based on the Lex engine as well. You might have heard of Poly, which is used for translation, and it's like a speech kind of an option as well. You can have text on a website and it can read it out loud to somebody. It can be for accessibility purposes as well. Basically, they are all based on the Lex, where you can create chatbots and all those kind of things. And then, as I said before, Amazon Connect is for call centers, for 999, other things. I mean, any kind of call center, based on their use case, they can use the capabilities of that. It offers you multi-channels, so omni-channel kind of thing. You can have multiple channels for chat and talk and all that kind of stuff as well available to you. And then you've got recognition. So Amazon recognition is used for, if you've got an image or something in front of it, it's a very simple example for that. It can recognize what that is. So like fire, or like an accident, or a person, or a dead rat in a cat's mouse who's trying to enter your facility or a building or something. So you can do a lot of things with that as well. So they are, the beauty of that is it's a multilingual kind of service as well. I'll talk about different languages that are available in Alexa. There are different languages that you can utilize. It can be in Arabic, it can be in English, it can be in Dutch, it can be in so many different languages that are available to you. And you can modernize the call centers and stuff. And these are speech-enabled different kinds of services. Probably you've seen them in fictional movies and stuff. And sometimes now we've seen demos of so many new technologies as well. So it's available there. And then reduce the cost structure basically as well, because you don't need to invest on building data centers. You don't need to invest on somebody looking after that as well. You just need to consume the service, and you pay the price for the service that you're consuming. So you don't need to really build the software from ground up. Basically, it's already, you've got lots of capabilities. You can tweak or customize to use for yourselves based on your use case. And then you've got enabled workforce based on that as well. Now, what are the different core services that AWS offers you to be able to do a lot of these things. So if we look at the image at the bottom, you'll see in terms of compute, you've got virtual machines like servers. You can have file server, web server, application server, different kind of servers you can create from virtual machines. They are available to you. You've got auto scaling based on the demand. Let's say I am trying to sell something in a year. I normally only need one web server to cater for my customers. But during holiday period or during special occasions, there's a lot of traffic that comes to my website or my application. I need to scale. I need to make it bigger so that it can cater for all the requests that are coming to it. I can use auto scaling where based on demand, only during that time, new servers would spin up and they'll shut down. I can do scheduling based. I can do, based on the target of, so let's say the CPU usage has gone up to 70% or plus, and I think it's going to be a bottleneck. I can spin up new machines based on that. I can just configure it and it'll do it for me. So those are the kind of things that you can do with auto scaling. And load balancing is where lots of traffic is coming your way. You want to divide the load of that. So you can use load balancing for application load balancing and network load balancing as well based on your use case, as I said before. Then you've got storage options. So in terms of storage, you've got object level storage. If you want to store files, videos, things like that, you can have S3 is a prime example of that. You can have block storage. You've got elastic block storage, which is like hard disks that are available to you, where you can use different things where you can update just the block level information, not the whole file needs to be updated. You can use it like a hard disk, basically. Archival as well. So let's say you want to keep data for a longer time. You've got, S3 Glacier kind of options as well, which are cheaper than normal S3. Those are the kind of things you can use. And then you've got import export options as well. You can import things into this and, data into S3 or somewhere, wherever you want to, and then export it to something else as well. It can be exported automatically. You can have scheduling, or you can transfer it as well within the AWS network from one region to another region, if that's what you want to do. And then you've got CDN. So we've got an option of cloud front. So if it's a content distribution network, so let's say you've got customers across. So I'm based in the UK, I'm based in London. So let's say I've got customers in London, but also up north in Scotland, and I've got some in Wales and others. So I want the service to be faster for them. So I can use these data centers which are built closer to them to deliver my content, and they can start caching that data which is frequently accessed. So they don't have to, the traffic doesn't always have to come to the source of where I'm storing that data. There can be a copy, a cached copy closer to them, local to them, so that they can quickly see something which other people have already frequently accessed as well. So that's another thing that is very useful. Then in terms of databases, we've got relational database, if that's what you like and that's what your application requires. You've got so many options in there as well. You've got MySQL, MariaDB, PostgreSQL. So you've got lots of different options there. And then you've got NoSQL. So imagine you've got unstructured, semi-structured kind of data. You don't have structured data, and you don't want joins, and you don't want to have a relational tables, and your application doesn't require it because any unexpected data can be stored. You can't define the schema of your database. Then you can use NoSQL. You've got a prime example of DynamoDB that's available to you in there. And then we've got caching options as well. So as we talked about CDN, content delivery network, we've got the caching capability of temporary storage for frequently accessed data, which would remain there for a while, so that people can keep on accessing it from there rather than going to the source. The network traffic doesn't have to travel across a continent or something. It is available locally to you as well. And then migration services. If you want to migrate data from one place to another, from on-site or on-premise to the cloud, you can do that. You can migrate it further to other regions and things like that. And then we've got networking capabilities as well. So in terms of networking capabilities, you can create your own data center, virtual data center in the cloud called VPC, virtual private cloud. You can create that. You can have direct connections with that. So you can have a fast, stable kind of link available to you. And you can do Route 53 and those kind of things, which are for DNS purposes. So you can register a domain, you can do load balancing of the traffic as well. You can actually do a lot of different things with that. That's an advanced scalable DNS service, Route 53, available to you as well. So a lot of this actually makes all the different things possible. And that's the core services. Now, security and compliance, we've got so many options as well, because a lot of customers are worried about if the data is secured, if they can be, what if there is an attack, a cyber attack on our data. There's been a concern that we've got all these systems online. Let's say we've got the power system, atomic plants and all that kind of stuff, power grid and everything. Airport ports, they are connected. Lots of devices are connected. What if somebody hacks it and takes control of that? So that can be a disastrous situation. So for that, we've got compliance and security available to you as well. You've got IAM, which is for identity and access management. So access control kind of a system. You can create users and things like that. You've got key management system. You can create your own public and private kind of keys. You can use it. You can store the keys there, and you can do your own certificates. You can create your own certificates. You can use the ones we can offer you as well. So those are the options that are available to you. There are lots of different options. Don't want to go into detail, but yes, that is for key management system. We've got monitoring a log. So you can use something called CloudTrail, which gives you access to all the API calls that have been made to your account, to different services in your account. So you can see who's accessing it, what's going on with that. You've got CloudWatch, which can monitor different services for their health. It can monitor different, and it can do some kind of an action, send a notification to somebody, and lots of other things as well. Then you've got configuration compliance. You don't want somebody coming in and just changing the configuration of your system. So you can have AWS config, which can monitor if you set a base standard of this is what I want my system to have, all these softwares and these kind of things. Nobody can tweak it. If they do, you will be notified that something is wrong with it. It's not compliant anymore. You've got a web application firewall. You've got assessment and reporting, so you can check a lot of different reports on different things, and resources for auditing as well. So a lot is available to you for all different kinds of use cases and purposes as well. Let me just check something. Okay, don't worry. I was just checking if there is a question for me or something. That's fine. Now, in terms of emerging technologies, I mean, they play a huge role here. So we've got Internet of Things. So you've got edge computing, where we're not talking about the cloud, which is more of a central kind of an approach. We're talking about distributed computing here. We're talking about edge computing, that because lots of workloads. So imagine there is a fire in a building. You don't want the alerts to go to the internet because of congestion on the internet. The message, by the time it reaches somewhere and by the time you get a response, it might be too late. So you want local decision making, local response in that case. So you can have that. You can have distributed computing possibility as well, because lots of the data centers are in close proximity to where you are. So you can use those as well for these purposes. You've got device management, as we talked about before. You can monitor devices remotely through IoT, core and things like that. You've got security analysis that you can do. Artificial intelligence can be used for video recognition, voice services, chatbots, for different public service. When you call a licensing department, they normally have a machine talking to you. So you can you can create those chatbots. They're not always text-based. They can be voice-based, basically. And you can train them based on the kind of questions somebody would ask. And machine learning, you can forecast different things. So machine learning can be really useful for that kind of a purpose. There's so many use cases, but in that case, and data lakes, they can have petabyte of data stored for you. It can be text, video, audio, any kind of data that you want to store. You can store it in data lakes, basically. And in terms of augmented reality, the user interaction with data is also a possibility as well. Now, as we talked about other things, is there any question, by the way, at this point? I'm more than happy to carry on. I'll give you the opportunity in the end. Is there any question at this point? Okay, don't see that. That's perfect. Thank you. So it's all about data, and the data can come from different sources. Data might be coming from internal data sources that you've got. It can be open data that's available to you publicly. It can be sensor data. As we were talking about IoT, different devices on the field can send you data about what's going on in your city or the whole country, probably. Citizen data can be collected through that. You've got external data feeds for weather and all that kind of stuff. You can connect it, just like you might have seen on websites. It's a simple thing. You can pull the data for weather on, you must have noticed it on certain websites. You can get weather updates and things like that on a side. You're looking at the main content, but on a side, you're just continuously getting updates of different feeds. It can be social media feeds as well. So you can capture, compute, analyze, and store the data, basically, and you can build smart solutions based on the data. If you don't have data, you can't predict. You can't tell what's the difference or what can you do about it. So you need to have enough data, and to store enough data, you need to have a huge infrastructure, and that infrastructure is available to you in the form of different options that we offer as AWS, basically. So some examples are this exact. So if you look at this is a Kansas City, Missouri. They've got smart city platform. So what they are doing is save up to 50% on road maintenance cost. So they can monitor what's going on the roads, if there is a congestion or something like that. So you can see on the image, there is a little box, if you can see clearly. It talks about vehicle 0% congestion is green. Then you've got 50% congestion. It's like a yellow circle, and the 100% is red circle. At the moment, you don't see any of the red. You see a little bit, but mostly yellow and green. So you can tell if you need to improve road network, or if you need to do something about it, basically. And in just 1 million events per day, there are lots and lots of events that happen, and it keeps on capturing that data, enables rapid testing as well at the same time. So you can predict different things, what's going to happen. Let's say it's a Christmas period when it's really busy, and you want to see next time when it's busy, what I need to do, what kind of routes can I make available to different people to use, basically, when you have to divert traffic, not like everybody's getting stuck into a worse situation. So you can do those kind of things as well. And this is more of AI-based and contact center-based solutions where you can find out different things as well. Another example is Louisville. So if you look at that, you can see, probably it's very small. Sorry, on the right-hand side, if you look at the image, I can see there are accidents, 2 accidents which it's identified. So the cameras would look at it, will look at where the location is, the coordinates of GPS, and it will tell you there is an accident here. So you can find out what you can do if you need to send an ambulance or something else. You can see traffic jams. There are 4 traffic jams in the area as well. So these are also possible. So now you've got the capability to monitor the bigger picture. You look at the bigger picture and you can respond based on the need, instead of sending somebody out without having any issues, and unnecessary patrolling as well. You don't really need that. You can send somebody if you need something there. And there are like 25 hazards identified. You can find out what was the problem, why it happened, and you can, if there is a blockage on the road, or if there is a maintenance going on or something else, you can find that out as well. That's another example. Now, next one is Open Grid. So in terms of Open Grid, this provides you, so this is a Department of Innovation and Technology. So they have developed this. This is a map-based application, and it's for citizens to understand what's going on in their surroundings. So there are 600 public data sets that are used for this. So if that, let's say, some kind of an event is happening, some incident has happened somewhere, it can notify the citizens about what's going on, what they need to be careful about, and how they can act in that kind of a situation as well. So, and it's all metropolitan kind of a data that is available to them, that they can make use of. And the next thing I'll talk about is voice. So a lot of people have been discussing this, that touch is not the way, to communicate. So the primary user interface used to be touch. Now it's going to be sound and those kind of things. So for that, you've got Amazon Alexa, and these are the different languages it supports. So as you can see on top, it says Arabics. Then you've got English, different versions of English as well: French, German, Hindi, Italian, Japanese, Portuguese, Spanish, different, dialects as well, basically in there. So you can use it for different purposes as well. And this can be really useful if you want to. Now you need to think about what kind of application can I build. You can develop application based on that. It's used by many for different purposes. I'll give you an example in a second as well. But this can be used for different purposes where you want to develop an application that can help serve the public, basically. That's the main reason why we would use it. So as an example, Alexa voice enabling content. So you can do a lot of things. That's what they've done. You can ask the government of Georgia to find out different things. So find information on food stamps. You can do like out-of-state licenses if you need to find out. You can even, register a fishing license as well, if that's what you need. So we've discussed a lot of different technologies and a lot of different things that you can do. There are lots of examples. There are lots of use cases. I would say, please review different use cases for smart cities and these kind of things on AWS documentation, on AWS website. Go through different documentation. You'll find a lot of useful case studies and how different companies are leveraging different technologies that are provided by AWS to come up with different things. And they are mostly focused on sustainability and these kind of things. So you can, I would say, please focus on those ones because they are more relevant. You can get ideas about how I can develop an application. It might already be out there and you want to tweak it further, just like you want to check if there's a fire in a forest somewhere, if you want to find out the water levels in the city or in the canals or, in rivers closer to you. So main water supply as well. And also you can see if there's a traffic management system you want to support. So you can build your prototype or something based on that. It has to be a more of a smaller proof of concept if you want to do that. And you can use a lot of different services. But look at that and you will find, you'll be amazed how many things are happening around you. Now, this was my main presentation. I just wanted to give you the opportunity to ask any questions. Next 10 minutes, if there is any question, please do ask me. My presentation is done. Thank you very much for that. I'm gonna stop this and I want to see the chat if there is a question. Is there a question from somebody with regards to anything? I'm going to bring it down. Let me just stop sharing on there. You're welcome. You're welcome. Is there anything that you would like to ask?